may introduce our moderator. Our moderator is Betsy Woodnap, class of 1964. Betsy has been a leader of the Wellesley community for many years, certainly throughout my time at the college. She is a trustee emerita, member of our Business Leadership Council. She is a member of the Campaign Executive Committee, and she was a co-chair of the previous campaign that was so successful for Wellesley. Betsy and her husband Bud live in Colorado, and they develop eco-agriculture projects there. And one of the greatest pleasures I ever had as Provost Dean was visiting that ranch a year or so ago. Betsy is committed to the integration of technology in the classroom and to innovation in teaching and learning across the campus. And that commitment that she has made to innovation in pedagogy is visible across our campus, has an impact every day in the education of our students. So she is the most apt person that I can imagine to moderate a panel entitled From Intro Hub to Living Laboratories. And I will hand over the gavel.
Thank you very much, Andy, and welcome everybody. I'd like to ask my fellow panelists to introduce themselves. Tell us more than one sentence, please.
So, hi everyone, I'm Kathy Suma. I'm a member of the class of '83, and I'm back at the college now in the role as director of the Science Center. I came back here about 6 years ago in January after teaching for 20 years at a variety of public higher ed institutions. I'm a geoscientist by training.
I'm Christina Jones. I teach in the biology department and the ES program. I'm also lucky enough to be the director of the Botanic Gardens here at Wellesley. I've been here since 1994.
Hi, my name's Kim McLeod. I'm in the astronomy department, and I've been here for 18 years. I am not an alum. And I have my office over at our beautiful Whiten Observatory.
Hi, I'm Brian Jaden. I'm the chair of the computer science department. This is my 13th year at the college. I teach at all levels of the curriculum, and my research area, myself and my students, is at the boundary between computer science and biomedicine. So together with my students, we develop computational algorithms to sequence genomes, to find where the genes are and how they interact with each other.
I'm Mark Tuttle. I'm in the neuroscience program. I've been here about 11 years. I teach also at all levels of the neuroscience curriculum. And my research focuses on how hormones work in the brain to regulate behavior, and recently we focused on the role of estrogens in energy homeostasis.
Thank you very much. We're going to have a short presentation from each panelist dealing with their field of interest and what's happening in their areas regarding the science curriculum. And so I'm going to start off with Kathy, who's going to give us kind of an overview of what's going on.
So thanks, Betsy. On your science experience when you were in college, this picture may be evocative, it may not be, but I just want you to think for a moment before we begin about what science was like for you, what your takeaways from your science experiences were. They may be similar to this. We hope that you'll hear some things today that are very different from what you remember, as my faculty colleagues here describe what they're doing in the classroom that's novel. We put this picture up, though, to start us off, to remind us that the founders of our college, Henry and Pauline Durant, believe very strongly in the power of hands-on education for science for women. They brought excellent teaching collections to the college that you can still see on display throughout the Science Center today if you take some time and wander around, or if you go to the field house this evening, you'll be able to see some of those on display there. The Science Center created a home for science, technology, and engineering here at the college, and I'm going to try and do this. This is an aerial view of Observatory Hill, and it was so named because we have the observatory up here looking to the north on this image. It was built in 1900 And after that, the greenhouses were built in about 1925. And that followed then very quickly the construction of Sage Hall. And this is an image of Observatory Hill and Sage Hall around 1971, before the Science Center complex was built. The Sage Hall was built in 2 phases, 2 wings. The wing by the greenhouse, oops, sorry, hit the wrong button. Go backwards. So the greenhouses are back here. This wing of Sage Hall was built in 1927, and then that followed another wing in 1933. The first wing, the 27 wing, was built for botany, following on to the greenhouses, and then in 33, the zoology wing. And sciences were up here, or that part of science was up here on Observatory Hill. The natural sciences, chemistry and physics, were in Pendleton at that time until the late part of the 70s, when we built the Perry Dean Rogers building, the Science Center, which you see here. And the creation of the Science Center really enabled us to integrate the sciences here at the college with the creation of this tremendous focus space, this atrium space that we call the Focus. And this space enabled us to bring the sciences together and open up the sciences really to the rest of campus. You see here a Tanner Conference event that took place a few years ago. We have large college-wide events now in this space in the Science Center. Creating this home for sciences really enabled us to begin to think about doing science differently, and spearheaded a lot of interdisciplinary conversations about science by having casual interactions between scientists of all disciplines that were now housed here. It enables students to interact with one another really easily. And as the Science Center evolved, what you see in this image is the Focus and the L Wing and Sage Hall. In 1991, we added another building, the E Wing, which is kind of behind this picture. You can't really see it in this image, and I don't have an image of it to show you today. But that created the end of the start of the Science Center as we know it today, and roughly 300,000 square feet for science. So I'm going to fast forward. In about 2008, 2009, President Bottomley commissioned the task force on the sciences to really think about all things related to science at the college. And the findings of that report, interestingly enough, that work, indicated that the Science Center, despite its size, was straining as a facility to be able to accommodate all the work that was going on in science, especially growing programs, new and emerging and growing programs like neuroscience and computer science. We were struggling to accommodate all of the specialized research that faculty engage in across the disciplines, and to support changes in pedagogy that faculty thought were important to support student learning. Despite this, the task force found many strengths in the science programs at Wellesley College, in particular in its faculty, staff, and students. We found that majors were rigorous and very coherent. They prepared students very well for graduate programs. And they recognized that undergraduate research was really highly valued at the college and was an important part of, an increasingly important part of the pedagogies that faculty engaged in with their students. Despite that, let's see, this way, the task force also recognized that there was a performance gap between our science graduates who came from majority populations and those who came from underrepresented minorities. So this slide I recognize is a little hard to read, but in the upper part of the pie are our white students, the big green piece are Asian students, the blue piece are our Black African American students, and this yellow piece are our Hispanic students. The slide looks on, oh boy, that's the left. On the left, sorry, on the left are the numbers over the past decade of student enrollments by ethnicity in our introductory level courses, and compares that to our graduation rate of STEM majors by ethnicity again. And so what you see here is most obvious when you compare the blue and the yellow pieces of the pie. In enrollments in introductory courses, students are represented at roughly the rate that they're available on campus. Everybody has to take some science as part of their curriculum. But by the time we look at graduation, we see that we're losing by more than half our students of color from STEM graduates. The challenge that we face is that these students come to college wanting to major in science. And something is happening, the task force discovered, within our curriculum so that they are not persisting through to graduation. So that became the challenge that the science faculty have been trying to address for the past several years to help underprepared students persist in science disciplines. This is not to say we want everybody at the college to major in science. We want those students who come to college passionate and excited about science to be able to complete in science. We want those students who are passionate about humanities to finish a degree in humanities, but to have a really good experience with science while they're here. So that's what we're going to be spending most of our time talking about today. The task force also looked at what faculty knew about the research on how people learn science. And in the spring of 1999, this book called How People Learn was published. It represented a synthesis of about a decade of research on pedagogy and learning theory in cognitive psychology, and helped us begin to understand that the best way for students, all students, to learn science was to get involved in what we call engaged pedagogies. I won't read the bullets, but basically this is taking a student-centered approach to classroom activities. And at Wellesley, this shows up really well in the work that we do with our students in research. This is a view of our summer research poster session, and you can see that the place is packed, it's exciting, it's a really buzzing environment for our students. So, what do? Wellesley's vision for science in the 21st century is to help us close this gap. We want all students to have a really exciting experience with science. We know that from the research that what's good for all students is good for underrepresented students and vice versa. If we can apply these engaged pedagogies, the performance gap between underprepared students and well-prepared students, which may start out like this, does this in time. And so it's really important for faculty to think about ways that we can engage all students with science material. As Madeleine Albright recognizes, science is critical for 21st century careers. And the one thing she wishes she did was had more science in her background. So that's part of our goal and vision and what we're hoping to do as we look at these Science Center-wide programs that we're working on, both to increase persistence and to engage students differently in their experiences for science. I'm going to pass it on.
All right,
I'm going to be quiet.
I'm going backwards. No, I'm going forwards. All right, so there's a huge demand for research in science, right? The research is clear, the other research is clear, that student research in authentic, experiences where you don't know the answer, that's what gets people excited. That actually doing science early on in their career is critical. But how do we accommodate that? That's really, really difficult to do. We're really fortunate. There's some ways that we can do that with minimal logistics because of the way science at Wellesley is set up, right? So that science center where we're all in the same building and we run into each other all the time, that's key. Another thing that I like to point out is that Science Hill is surrounded by botanic gardens. We talk about this campus as a living laboratory, and those botanic gardens are a living laboratory with an incredible diversity of species, soil that you can sample, you can dig things up. There's just an incredible number of opportunities to engage in authentic research right there. I like to say that, Harvard's got an amazing arboretum, if anyone ever go to the Arnold Arboretum, but it's a field trip to get there from their campus. It's not in Cambridge, right? So here we have 22 acres surrounding Science Hill. It's really a phenomenal opportunity. So as an example, here's a little thing that we did right outside the observatory, still going. It's a long-term project comparing synthetic and organic approaches to growing spinach and carrots. And we set this up for a first-year seminar in environmental studies. the person who teaches that, Jay Turner, is an environmental historian, but he wanted to include some actual science in his first year seminar. So this is the first semester that students are in college. And they're all interested in, well, you know, what does it mean to grow organic? Is it really better for me? Does it taste better? All that sort of thing. And in this seminar, just as one part of the thing they're doing, they've got these 20 boxes all lined up right outside where they've got their class in the observatory. And they are harvesting, they are taste testing, they are taking chlorophyll measurements, they are doing soil sampling, they're doing lots of different things, testing hypotheses right there. And this started 3 years ago, and we've got students now that have gone from that class into Botanic Gardens internships, didn't know they were interested in science before that. One example. Another one, again, right outside the observatory, you guys are well served. We've got this edible ecosystem teaching garden, which is kind of biodiversity meets food. And in both of these examples, the Farm in a Box and the edible ecosystem, it's a kind of research platform that you can engage with at that introductory level, ask some fairly simple questions, but it's also got serious depth to it, right? These are long-term projects. We're going to keep those farm-in-a-box treatments going year after year, right? So that you get only organic chemicals applied to the organic boxes, only synthetic in the others. We can see how the soil changes over time. And so students are plugging into, you know, previous year's data and looking at how things are changing. And this is something that then a thesis student can jump into and look at the longitudinal data. We've actually got upper-level microbiology classes analyzing, oh, the microbes are actually diverging in these two. And, you know, we're going to get publishable research out of this. This is not something anyone else is doing. Similarly, the edible ecosystem, there's just a gajillion possibilities, right? And it's right there. Students can roll out of bed, check out their research plots on their way to class, right? And that's the way to do science, right? It's part of your daily life. Then we've got this super exciting opportunity that's going to be afforded when we renovate the greenhouses. So we've already got amazing greenhouses, right? If anyone recognizes that photo in the upper left, I think it was 1949, the students then really studied plants. Lots of people like to say they seem to be listening to the plants there. Lots of different ways to engage, but they're in pots for the most part. What we're going to be doing with Global Flora, we're going to take this incredible diversity of plants, put them in the ground. We're going to have different kinds of soil in different areas with a lot of sensors underground. We're going to set it up as a research platform so we understand the physical and chemical situation underground, and we overlay a huge diversity of plants on top of that. And we study how they deal, right? It's really indoor ecosystems. So those other, you know, edible ecosystem and Farm in a Box are great if you're here in the summer, right, or end of spring or beginning of fall. But in the middle of winter, you got to go into the greenhouses to do this kind of research. So Global Flora is going to be, it's going to add a lot to our abilities to support research, including at the introductory level. All right. I'm going to talk just a little bit about how I teach my introductory course, and so it's a course that people take to fulfill the science requirement, as well as if they're a first-year student potentially interested in science. I don't assume much background in science, so again, I'm trying to engage everybody. This is a photo from Betsy's year, 1964, in the botany lab that still exists in Sage Hall. And you can see that Harriet Crichton, I should point this way, Harriet Crichton is lecturing to students individually at their little, you know, desk with arms, but she's got a whole array of plants. She's going to try to engage them, but it's very individualized learning, right? It's a professor professing and the students writing things down, and I'm sure she engaged them. I know that she used the greenhouses a lot, but the studio style is integrating the lab experience, which right now is separated, into the lectures and discussions. So you've just finished talking about photosynthesis. Now we're going to actually test it, and then we're going to go on to the next topic. It's all smushed together. You have some ongoing projects that really get, I keep using the word integrated, but they just get integrated into the topics so you're building the skills in as well as the actual core concepts. You sort of bring those in together with some authentic research. And I know there's, many of my other colleagues here are also starting to do more and more with this studio-style approach. It's not the only best approach, but we're really excited to be able to do it. And I'm going to be doing it in the Greenhouse Visitor Center because there isn't a room that accommodates this kind of thing right now in the Science Center. So.
All right, I'd like to build on some of what Christina said, but first I'd like to thank her for growing me such delicious lunch, which we get to take advantage of in the summer when we're here with our summer research students and the berries are growing on the hill. We're allowed to sample a few. As I said before, I'm fortunate enough to have my office in our beautiful Whiten Observatory, which, although it was built in 1900, underwent a terrific renovation about 5 years ago. And part of the impetus for this renovation was to create the kind of spaces where we can do the kind of teaching that Christina was mentioning. And in particular, this room this beautifully lit room here that you see on the left, this was designed by a team of faculty members in conjunction with the architects, faculty members from different departments. And so this is now a sort of a test case for the kind of space where we might be able to do this kind of integrated teaching, maybe in the Science Center. And so we have in this space environmental science labs going on, and geoscience labs going on, and astronomy labs going on, and interdisciplinary combinations thereof. So let me show you a picture from one of these classes. This happens to be a geoscience class. It's an intermediate level class. It's not an introductory level class. And I'm sorry you couldn't see the whole room because this is a room that has whiteboards surrounding on several sides, and at any given time you might have students that are analyzing data up here from a graph on the front. You have students that are working on small groups on a different task over here, other people at the whiteboard preparing to present what they're doing. It's really just an energized hub of activity. And in this particular course, the idea is, as Christina said, to break down the artificial barrier between what we would call lecture and what we would call lab, because that's not the way that science really works. And so the students in this course, for example, might be analyzing the heavy elements, the contaminating soils from different places, and then coming back together and building the big picture of a particular site or a particular project. And the deliverables in this case aren't the usual exams and so forth, but rather scientific posters like you would take to a meeting, and in fact, some of them do. So that's just one example of what happens in a room like this. And another example is something I did a few years ago. This was a first-year seminar that really embraced the idea that it's important to get students involved in authentic research right away, particularly for women in the sciences. And so this project was a first-year seminar where I had brand new students, and they were trying to answer a question for which nobody knows the answer. And so what I've been doing in my research lately is I've been looking for planets around other stars, these so-called exoplanets. And this turns out to be something we can do from right here on Wellesley's campus with our 24-inch telescope. And so we have a star, and if the stars are aligned just right, the planet, every time it goes around, blocks just a little bit of that star's light. And you can detect this kind of dip in the star's light. But I have colleagues at Wesleyan University and Swarthmore College, and we were interested in what we might be able to learn about these systems if we combined forces. And could we, for example, determine new parameters for these planetary systems? And the answer was we didn't know. So we designed a first-year seminar where the students would help to answer this question. So starting from zero, they taught each other, really, about exoplanets, what was already known, and they learned how to use our telescope. And then they took data, and the students at Wesleyan did the same, and then we combined the data and had the students put some limits on what kinds of things that we might be able to learn. And again, the deliverable here was a scientific research poster that the students did, therefore by carrying an authentic project through from start to finish in their first year at the college. So this really is a way for us to model the scientific process in an authentic way. I don't know how many of you are scientists, but those of you who are, science is messy. And science, the outcomes are never guaranteed, and you go down the wrong path more often than you go down the right path, and maybe you don't get an answer that means anything at all in the end. And that was definitely what was happening here. We didn't know ahead of time what was going to happen. And that there are multiple approaches to any scientific problem, and then in fact, to do a problem like this, you need people with different strengths to bring their strengths to a project. So that's the kind of thing we are doing in our studio-style space over there. And I think, maybe, as I said before, we can use what we've learned about the construction of that particular room as we think about how we want to configure this space in this building. So I'll turn it over to Brian.
Thank you. Well, I'm curious to hear the results of the exoplanet project. Perhaps I need to take this first-year seminar.
If you read the fine print on the poster.
I see, on the slide there. So I was hoping to just share some thoughts from the perspective of the computer science department. As I expect you probably know, nationally, women are vastly underrepresented in the field of computer science. So nationally, undergraduate degrees in computer science, only 18% are awarded to women. I'm happy to say that at Wellesley, when we award CS degrees, more than 18% are awarded to women. Indeed, computer science is booming here at Wellesley. So in the last 5 years, our enrollments have doubled, our number of majors has quadrupled, and it's now the case that 2 out of every 3 students at Wellesley take at least one computer science course. So I'm pleased by the interest that we have. And I think that there are lots of reasons contributing to this interest and growth in computer science. But I just wanted to touch on a couple of the things that we're doing here at the college, both to encourage this and in response to this as well. So one of the main things has been major curriculum redesigns. Using many of the techniques that you've heard my colleagues express already so eloquently. So this is, and of course, as they've illustrated, this is based on a large body of research from the literature, evidence that indicates how students best learn science. So our courses are now seeing increasing amounts of small group activities in them, an integration of teaching and research, high visibility, so meaning that other people can see what's going on as students are engaged in learning and in research. We're trying to have problems that are compelling problems, motivated by the world that the students live in, and demonstrating the interrelatedness of the different disciplines. So as just one example, in computer science, we have courses cross-listed and part of programs here in the Science Center with physics, with biological sciences, with cognitive sciences. And then outside the Science Center, we also have courses that are cross-listed and part of programs in lots of other areas, with the education program, with the cinema and media studies program, and we have a very vibrant program that we offer with the art department, our media arts and sciences program, that's very popular on campus. So we're trying to include all of these aspects, and I think a nice example of this, whoops, excuse me. This is not so a nice example. This is our Human-Computer Interaction Lab, HCI lab in the Computer Science Department. This was the lab about 3 years ago or so. Not a very welcoming room, in my opinion. The people are welcoming, but the space not so much. And then 2 years ago, actually to this day, we had a new HCI, Human-Computer Interaction Lab, that I think is, in my opinion, more welcoming environment. And you can see just in this image some of the things that we've been talking about. So for example, one of my colleagues, Orit Shair, is giving a class in there in this picture. You can maybe see her up there. And not only is the class going on, but actually on the right side of the screen, there are actually students in there engaged in research separate from the class, and it's easy in these classes for students to move back and forth seamlessly from lecturing to small group activities to research and exploratory activities, and it happens throughout the course of the class seamlessly. You can also see, I mentioned sort of high visibility, so we're looking at the room through a glass wall, as maybe you can make out in the picture, so that people walking by can see what's going on and the research and activities that students are engaged with at any given time. So if you haven't been down, this is first floor of the Science Center, I highly recommend you walk by and you see for yourself the buzz and hum of activity going on in this room. It's very exciting. And indeed, this photo, which is even a few months old, is already out of date because there's a lot of new equipment in the room now. We find that before we had so a lot of the national external funding agencies, they generally aren't going to fund physical space infrastructure. But once you have the physical space infrastructure, they're eager to fund the research and the equipment needed to engage in learning and research for the students. So we recently received a large grant from the National Science Foundation. So we have a lot of cool new toys in there. We have a very large table. It looks like a table, but it is a computational system, a horizontal system that responds to different interactive modalities, so touch, tactile interacting with this computer, and it's integrated with a large vertical computational system, which is like a data wall, also tactile touch integration for collaborating and analyzing these large data sets. So I encourage you to go have a look at these things. It also helps when you have cool toys in there. That is also good at attracting and retaining students as well. So these are some of our toys in the lab. When you have virtual reality stuff, for some reason, people show up. One of the other things that we've been doing really relates to building a strong sense of community within our department and program. So these are a few of the events that have happened just in the past month in the computer science department. So we tend to have about 3 to 4 of these a week. And what you see is, well, there's a variety. There are a lot of recruiting events. We have Microsoft and Google and Goldman Sachs, Uber and Facebook all recruiting our students. But what you see, most of these are initiated and run by our students in our department, our active CS club, and by alumni. We have programming contests. We had a hackathon here a couple of weeks ago. If you don't know about a hackathon, we hosted this event, so people from all over come and compete in a computer programming competition. They work in small groups over the course of a weekend. It's an intense coding programming experience over the course of a weekend, and they're competing in their groups to develop compelling software applications. We have So last month, we actually surveyed our students coming back in September, coming back from over the summer, and we asked them what they had been up to over the summer. And fully 15% of our students worked at just one company over the summer. It was Google. Google seems to be taking over the world, or at least our students, perhaps. But the second most common thing that students did over the summer, according to what they were reporting, was working with Girls Who Code. So this is a nonprofit organization geared toward motivating and teaching girls at the K through 12 level to get involved in computer programming and computer science. So 12% of our students were engaged in this. So one of the stats we have is that among high school girls, only 0.4% express interest in studying computer science, which is staggering. The number, I'm happy to say, is much higher here at Wellesley College, but I was pleased to see so many of our students working over the summer to make an impact in this regard. And a few days ago was the Grace Hopper celebration, which is the largest conference in the world for women in technology. It's an annual conference. It happened to just be a few days ago. It was held in Texas this year. And we had Wellesley was very well represented at this conference, so we couldn't get all of our students and alumni to meet all at once, so we had to have 2 different meetups. So here they are. And I think it is a source of pride among us to have Wellesley be or encourage make a high impact on the profile of women computer scientists. So it's great to see so much interest there. So I will turn it over now to my colleague, Mark.
Thanks, Brian. So our neuroscience is an interdisciplinary major, and similar to most or all interdisciplinary majors, many departments contribute to our majors, such as biology, psychology, chemistry, physics, and math. But what I want to focus on is this core set of classes that we offer within our major. About 7 years ago, 8 years ago, when we became an independent program, we revised our major, and what we did was we took our existing 200-level neuroscience course and made it our 100-level neuroscience course and sort of ramped up the remaining part of our major. As someone who studies hormones, I like to think of it as a neuroscience curriculum on steroids. But so because all of our majors take a known class at all levels at 100, 200, and 300, we know what all our students are getting. So when they come to the 300 level courses, we know what they've had and what they've done. And it also allows us to sort of scale up different concepts. So in 100 level, we might introduce learning and memory, but then at 200, they're going to spend a few lectures learning about learning and memory at the cellular and molecular level and really getting into it in depth. We can also ramp up critical thinking in the way of reading research papers so that we can introduce, I guess, more accessible research papers in the 100 level, but then by the time they get to the 300 level, they're reading recently published cutting-edge research in major journals. And in that, as part of that exercise, we actually have them write a full grant proposal in their 300 level course as on a topic of their choice that they spend the entire semester working on, and we go over grantsmanship and all the other aspects that are included in writing grants, and most of the students tend to enjoy it, I like to think. So also when a student comes to our lab wanting to do research, we know what research skills they've had from these courses so we can then build on it. And just as all the sciences here at Wellesley, we really emphasize research. And we think that exposing our students to research is important, and we think it's really a critical part of them becoming a scholar, which is, I think, really our main goal here. So these are various students who have done research in all of our research labs. We find that many of our students are really very committed, those who are interested in doing research. I've had students who have worked with me for all 4 years while they've been here. I had one student who started working with me in her second week at Wellesley, and she worked up through the morning of her graduation. And actually, I had a student who started working with me before she came to Wellesley. She started the summer before coming to Wellesley. So we really have students who are committed to doing their research and who really find a lot of joy and satisfaction in it. For example, here are two of my students who presented their research this past Monday at the Society for Neuroscience meeting in Chicago. This is a meeting where 30,000 neuroscientists from all over the world attend every year. This is there's very few undergrads. It's predominantly graduate students, postdocs, and professors presenting their research. These students were really mobbed the entire time at their poster. They actually had to take bathroom shifts one at a time. And I think these kinds of students really get a lot out of their research. They take ownership of their projects, they learn the scientific method in depth, and they really learn persistence and dedication to a long-term project, which I think serves them well later on in life. And these students can really make meaningful contributions to our research programs. So many of our students publish with us on peer-reviewed papers. In one case, I had a student who provided essential pilot data for a grant that I was applying for that I was able to get. And we've also had students contribute really in meaningful ways, both to outreach that we've done with area schools. And then here, just as in the computer science department, we also have an annual reunion at our SFN meeting. This is current students and also graduates from about the last 10 years. This is taken at the end of the night. These are the people who were able to hold on the whole night and stay the course. But it really allows current Wellesley students to connect with other students who are in the field, either in PhD programs, postdocs, or now we're having some of our students who are, have faculty jobs and jobs in industry. So it allows them to start networking with their fellow sisters in neuroscience, which I think has proven really effective. And we look forward to having this reunion every year. I think that's it.
Okay, thank you very much, all of you. I have several questions, and I'll let the audience ask some questions too. I want to ask Kathy, what happened to chemistry and physics? I mean, are they still?
Chemistry and physics still exist.
Yes.
They're thriving at the college. We just were limited in the numbers of people who could participate in the panel. So we opted for the panelists that we have today. But chemistry is doing a lot of very exciting work in the laboratories. We have faculty members who have just, as Brian described, a major research grant that was awarded to computer science. Chemistry was just awarded 2 major equipment grants. We will be bringing in a new nuclear magnetic resonance spectrometer later this year. It's already been ordered. It takes about 6 months to build, but it will be coming in to replace one of our existing units, and we're hoping to have that in sometime during the spring semester. This is an instrument that is used by every single student taking organic chemistry, as well as students doing all kinds of research. And we're also were awarded funding to obtain a new atomic force microscope, which is a new instrument to our suite of research caliber instrumentation here at the college. Physics is growing. We have a strong partnership between physics and astronomy and an astrophysics program. We have a relatively young new faculty member in physics whose research blurs the boundaries between astronomy and physics as he looks at dark matter. And I don't know, Kim, if you want to say more about that collaboration?
Sure. I can say he doesn't look at it because you can't see it.
Right.
Yeah. But he is trying to detect its existence or not. And he's been a really terrific addition to the physics program because he has students in the lab right away. He's got students banging down the doors to get in the lab, but he's had them working in his lab here building instruments that will do this cutting-edge dark matter detection or not. We don't know if it exists. The other thing I could say about the physics department is that they are trying to move towards a studio-style teaching in their introductory course, Physics 107. Maybe you took it. And they're doing a little pilot program this fall with that, teaching in the existing lab space. So it's something they hope to be able to scale up in any renovated spaces here. But we're glad to see them doing that because particularly for physical sciences, it's really, really makes a difference to get students involved in that way.
Can I
Yeah,
speak
please
up
do.
for the mathematicians who are also not here? They're the M in STEM. So it's really hard, as far as I can tell, to involve students in mathematical research. But we have some mathematicians here who are doing really innovative pedagogy. So they're involving students in some amazing ways, tackling problems that are really challenging from the get-go, and just integrating that into their coursework. So it's some of the same style, even though, discipline by discipline, we have different kinds of research. It still works to put that into the teaching.
And I'll finish with just one comment. Chemistry, you asked about chemistry. Chemistry is the one department within the sciences who requires all of their students to complete a research project as part of the curriculum. So they've really embraced this research opportunities for students. They can do it in multiple ways, but they all must complete research in order to graduate with a chemistry degree.
Excellent. I have a question now relating back to let's call it the older style teaching, where we had lots of lectures and there were lots of people in the class. I'm hearing across the board, you're saying the classes are smaller. You even talk about freshman seminars, which are, I'm sure, new or relatively new. Isn't there a, how do you cross the necessity for the student in science to learn a host of facts and a host of definitions as you combine the curriculum with research work? I mean, in the old days, and I'm saying old days, I don't know how old the old days are, because I think we didn't get an answer to your question about how many of you remember the lecture hall. But there was a lot of memorization at that point in time, and that's how you got introduced to science. So can somebody comment about where's the balance between jumping in and doing research and learning the facts and the concepts?
I'll say that when I started teaching my introductory course in 1994, it was in this room, and I was up here lecturing. which I never enjoyed doing. And, you know, there was a lot of facts. There was also the laboratory. What I have done, and several people have done this as well, is I've flipped the classroom. This might be a familiar concept. So lectures, you know, it's one pace. Yes, students, we try to make them interactive, but it's, you get it now, you take notes, and that was the content. Instead, I've recorded my lovely voice speaking over my slides so that the students can watch that as a podcast, it's probably not the right term, or read it, or for students for whom English isn't their first language, they can watch it and read it at the same time. They can review it if they need to. They can do it at different speeds. They do that as homework, right? So that's the individual piece. That lecture piece, that one-on-one, well, it's teacher to student piece is happening at home for the students, which makes it so that in the classroom we have time to work on problems together, right? To do things that are much more interesting, I think. So it's not just about, you know, the rough endoplasmic reticulum has ribosomes on it. It's more about, all right, how do we get from genes to the phenotype? And what are the questions that you're interested in that we can really start to illustrate these concepts? And so we do things in class, whether it's actual research or just investigating those questions that come up because they've already had to become familiar with that content at home as homework. So we've really flipped how we use the whole class time, both in class and out.
Mark?
And so just to expand on that, I think Christina's concept of doing is really the key, and I think doing can extend to a lot of different areas. It can extend to doing research in the lab where they come in after class and do their own independent research, and I think then some of the words and terms they've learned in class really make sense because then they're doing it. And other ways is to go out and meet people. So in my class and other classes, we actually attend meetings. So I take my neuroendocrinology class to a symposium, a full-day symposium. They read the research articles of the speakers before they go, and then they meet the speakers and have lunch with the speakers. And I think that's a real motivation for them to not memorize the terms, but learn the terms and learn the concepts so they can discuss them in a meaningful way with these people. So I think it's about doing and not just memorizing.
Do we call that active learning now in your parlance?
Sure. Sure,
Okay, but there's
I
a
think
lot of
active
words that
learning-
are bandied around about what kind of learning this is. You know, experiential, active learning. There's blended learning, and there's probably a host of things I haven't heard about yet. But
But I think it's understanding that learning goes well beyond the classroom, experiences that aren't just confined to a 50-minute or hour-and-a-half-minute period. Right?
Let me ask a question of you all regarding this. How many of you remember when you were in college cramming for an exam? How many of you remember the content that you crammed? One. Wow. So the point is, by the act of doing helps you remember what you did. So by engaging students in these authentic experiences, they actually learn more content more robustly than if they are lectured at and have to memorize that content. So,
can we come back to school?
I think there's an alumni college, isn't there?
Yeah, yeah.
I have a question, and I got here late, so I may have missed the answer to it. Last night, I was talking to someone whose high school daughter is interested in engineering. Can she come to Wellesley? There's no engineering major at Wellesley, is there? So,
The question is about engineering, availability of engineering at Wellesley. Do you have?
I'd like to say that I was one of the first students who took classes at Olin College, so now there's a bigger program that encourages students to be able to take engineering. They had piloted some classes when I was a student here, where the Olin professors came over and taught the engineering classes, so they brought engineering over to foster that relationship.
So you can come here and take classes at Olin?
Correct.
Yeah, we have extended that program now. We have a program we call the WE Lab, Wellesley Lab, Wellesley Engineering Lab. It's, we have a faculty member who teaches that program. We teach the first 4 courses in an engineering curriculum, and after that, students are encouraged to continue at Olin or at MIT. So the idea is to introduce students to engineering in a liberal arts context, and then take what they've learned here and go off and finish elsewhere.
Kathy, can they major in engineering, and does Wellesley give a degree, a bachelor's in engineering of
There's
some?
a 5-year plan. I think it combines with Olin, right? You can do a 5th year and get some kind of engineering, I don't know if it's a certificate or yeah, I'm not sure.
Andy, do you know?
We do not give degrees in engineering.
Yeah.
Students can. We also have a course with MIT where students can both get a Wellesley degree and an MIT degree. But no, we don't have it.
A classmate of mine, hi, how are you? A classmate of mine, or ours, class of 80, majored in physics here and got an engineering degree at MIT in 4 years. So that's always been a possibility and I guess continues till this day.
My
Jess?
class for the 55th reunion has developed a fund that pays for a professor who will introduce liberal arts majors to projects that need an understanding of engineering, whether it's clean water, Taco Bridge, or something like that.
That's part of our We Lab programming. Yeah. So thank you.
Thank you. Let me ask Mark, what has happened to, tell us a little bit about what your students do after graduation and how this curriculum has helped them in their future.
Oh, okay. Well, I'd say about half of our neuroscience majors go on to medical school, and the remaining half, probably a little over half of them, go on to PhD programs, and then we have students, PhD programs in neuroscience, and then we have a number of students who go into public health, teaching. We've had one that went to work on Wall Street, and scientific writing. I think for the second part of your question, I guess the student I alluded to who worked up until the morning of her graduation, she went on to go to get her master's in public health at Cambridge in England. She got a full scholarship to go there. I think virtually all of her classmates were physicians who had already been through medical school and were practicing, and some older students, and she ended up winning the Best Thesis Award, and she attributes that to her experience here at Wellesley. We have another neuroscience student who was on a publication here at Wellesley. She went into Harvard. She went on to Harvard Medical School. She's now doing a residency in neurosurgery at Brigham and Women's, and she sent me her CV just a couple days ago, and she had 13 publications on it. So somehow in medical school, she had 12 more publications added to her CV. I have no idea how she did it, but
Wow.
I'd like to think that her experience here helped her. And others of our students who have gone on to PhD programs really attribute the experience of learning how to critically read research articles, which I don't think is done at all places, but we really emphasize it here, I think, in all our classes, really attributes their success in PhD programs to entering PhD programs knowing how to do that, which is a real leg up from many of their other classmates.
Thank you. Christina, I have a question for you. And others can please chime in, but I think this is near and dear to you. When you're doing a flipped format in your classes, do you have enough room and space to be able to talk to the class in a more formal setting, and then say, now let's move and do some photosynthesis experiments? Are we set up? Do we have room for all of this, or is that part of our problem, like a physical
Right.
constraint?
Right. We are not well set up for that now. I had been teaching in the observatory most recently because they have more flexible space, and I do have students getting up and moving around and doing things on the walls a lot. But we don't fit in that really nice lab classroom that Kim had shown. And there isn't a space in this building that can accommodate 48 students doing things in groups of 6 or 4 or however many. So that's why we're going to use the Greenhouse Visitor Center, which is going to be exciting, partly because visitors to the greenhouse go through that space to get to the greenhouses. They'll see active learning going on all around them. But having a space like that that's near to the greenhouses so that we can incorporate the lab bits, it's going to be a bit of a 3-ring circus where a lab instructor will take groups of 16 into the greenhouses or into the lab, and we'll sort of rotate around, and then we'll all come back together for some whole group activities. So we need some fairly specific space, except that it just needs to be set up specifically during that one semester for that class, and then can be used flexibly for other courses in other semesters.
And Kathy, I'm sure you have, I'd love to hear, and I'm sure the audience would like to hear about how the setup now between SAGE and the Science Center lends itself to some of these teaching styles, from studio to flipped.
Well, so I think it's a testament to the tenacity and the creativity of our faculty that they are able to engage at this level that you've heard today in the spaces that we have. The spaces that we have are not all that conducive currently to this style of pedagogy, but we're hoping, as we plan further for renovation of the Science Center, that we will be able to create spaces that are far more conducive to this kind of approach. So I think, did I answer your question?
Yeah. There might be some questions from the audience, yes.
I have a question. So I'm involved in innovation at MIT now, and so this is kind of my big concept now is all about innovation and entrepreneurship. And I wonder to what extent the sciences here at Wellesley are fostering a culture of innovation and entrepreneurship, because I think that a lot of stuff can come from science. So I just wondered what the creativity quotient is for innovation and entrepreneurship.
I think that's a good question, Beth. I'll say that the engineering studio really fosters that. Our plans to renovate the Science Center include the development of an intro hub, which was in the title of this panel. And that intro hub is designed around the idea, here's a picture of it, designed around the idea that we would take the level of the focus, the atrium space at that ground level, and renovate the spaces around that mezzanine level of the library, around the focus, so that we had an intro hub, and that would be the center of that space would become a maker space, a shared instrumentation space that all of these intro labs could spill out into to foster that creativity and get students thinking in that regard. So this image at the top shows just a schematic from our planning of what we were hoping to do. The image right below it is taken at St. Olaf College, and this is an idea that they did with one laboratory of making the lab visible, enabling you to see into what students are doing off of a common space. And you can envision this, if you think about the common space shown in this image, as our focus space, and then this being one of multiple labs that were ringing that focus space there. I would be happy to talk more with you about it. I'll just finish this up. The last image on, that would be the right, that's labeled Global Flora Schematic Model, is just a model that we created as we went through the schematic design program for what the new greenhouse might look like. So Christina told you about some of the programming that we're hoping to be able to achieve there. The design for the new greenhouse is really quite spectacular. It's this curved and soaring building that we hope will allow lots of light in and develop some excitement around.
Brian, I have a question for you. Obviously, you've talked a little bit about the growing interest in computer science. A two-part question. Do you have a lot of majors in computer science who are dual majors? So they're taking computer science plus something else. That would be one part of the question. And then can you tell us a little bit about what has happened to graduates from the computer science major program?
Yeah, it's a great question. So yes, to the first, which is, do we have a lot of dual majors in computer science? Absolutely. I think it's a point of pride in our department a little bit to have strong connections throughout the rest of the college. So I was mentioning the classes and programs that we have jointly with many of the other fields, biology, cognitive science, physics, education, media arts and sciences, et cetera. So we have lots of those formal connections, as well as a broad range of, when you look at the distribution of our students and their majors, and particularly the double majors, you see students majoring in computer science and other fields, but it's not particularly enriched for one other major, like you're always seeing math and computer science or some other combination. Yes, we see that, but there's a real, a broad range. So it's seeming increasingly, from our point of view, the students that are interested in majoring in computer science are coming from across the college, and they're doing something, and they also want to have computer science as a major, which we love because we're trying to foster these connections, right? I think this is really important to demonstrate the interconnectedness and interrelatedness of different disciplines. Which I think is a great thing, and plus I just love it when people have an interest in computer science. But that's my own biases. And then the second part of your question.
After college.
Yeah. So again, I think it's interesting because there's a very broad range of what our students do. So we have students that go off to graduate programs and are very successful in graduate programs. We have students that go off into industry. I mentioned a strong connection to Google, for example. That's seems to be the flavor the past couple of years. But before that, Apple was very common for our students to be going to, and now Facebook seems to be increasing in its representation among Wellesley alumni. But yes, we have very strong connections with industry, both sort of the traditional technology companies, large technology companies, as well as the startup companies. But then there's also this very broad range of students who are going off into all sorts of non-computational technology-related fields. So we see plenty of students go into teaching and architecture and medicine and business and any number of other fields, which I think is great, and we definitely want to sort of encourage those interests, because I am of again, my own biased mindset that no matter what field you go into, it's beneficial to have some kind of computational exposure or background, but certainly science, if not.
Absolutely. Kim, question for you. The underrepresentation of STEM is obviously on the minds of great minds, as well as all the great thinkers, and concern about how the nation is going to increase the presence of women in STEM professions, as well as in majors in college. What are you doing and your faculty colleagues doing to draw young women into the STEM subjects?
And I'm going to speak specifically here about physical sciences, I think, because the underrepresentation is most pronounced there. In physical science, computer science, and mathematics and engineering. You've heard some of those other subjects already, so I think I'll just say here, I mentioned that our physics department is thinking about the way it teaches its introductory courses and so forth. And the math department is engaging students in research and with first-year seminar programs. But I think one thing that we're going to do to target underrepresented minorities and first-generation students and other students who might not think of themselves as scientists when they come here is to sort of sneak them into physical science through some interdisciplinary courses. And an example of one of those is a course I'm going to be teaching this spring with my colleague in the geosciences department. It's going to be on planetary habitability, including our own planet, mostly our own planet. And this is something that we hope will be attractive to students who might not consider themselves scientists. And in our two departments, we have a long history of having students take our classes who didn't have a particularly good high school experience in science, for example. They already know they hate science, biology, and chemistry and physics are too hard, but astronomy and geosciences, those sound like fun. And then they come into our courses and learn the truth of that old adage that astronomy is just physics in disguise, right? So we're going to be partnering together to teach an interdisciplinary course, and we're working with our class deans to identify students who might be good candidates for this program. So that'll be in the spring, and then other interdisciplinary courses like that, I think, to attract students into science. And something we haven't mentioned too much, I think, cuts across all of the disciplines, which is the Science Center Summer Research Project. And that's particularly critical for physical scientists. But maybe, Kathy, you can talk a little bit more about that. But every year we have about 100 students, I think, participating in our summer research project. And in the physical sciences, we've been making an effort to get them younger and younger. And so it's not that they're really going to be that helpful to your research, but you're giving them that early experience that motivates them to want to then hang in there in that physics course. Yeah.
Do you want to tell about the summer program? Or-
The summer program, as Kim said, we have about 100, 120 students each year. It is supported largely by endowed funds from generous donors to the college, and it enables us, we've recently had some gifts that have enabled us to focus explicitly on positions in the program for first-year students in the summer between their first and second year, as well as other funds from the Sherman Fairchild Foundation, which enables us to explicitly support students who are the first in their families to go to college, who are from low-income backgrounds, or who are from underrepresented minority groups. And by making these changes in our summer program, we've been able to both increase the numbers of students who participate and broaden the scope of the students who participate in the program. Those students, once they participate once, they want to keep coming back. It's like they get bitten by a bug that gets them excited about science, and they can't stop. They don't want the summer to end. They want to keep going. They buzz during that summer research program, and they're so excited to be able to stand up. They're terrified first about having to present a poster and stand there and talk to people about it, but when they actually do it, they come back just on cloud nine. Their confidence goes through the roof, and it really, all of the research demonstrates that much of retaining students in science is about, especially for women, is about building confidence, because we are so socialized through our K-12 programs and beyond that girls can't do science, girls can't do math, all this nonsense, real nonsense. So we make a real effort here to engage students early and often in science, and we are building other programs with the help of some funding agencies to create what we're calling the STEM superhighway, with multiple on-ramps onto that highway. And once we get students on that highway, we want to help them see how to keep moving forward. We're blocking the off-ramps as best we can. So once they're on, the only way off is at graduation. That's really our goal.
And if I just add,
Mark?
Betsy, I think it's just to sort of emphasize what Kathy's been saying. I think these summer programs are really critical for the success of science. I think that science is a Wellesley. I think this doing research during the year is great, but I think that's when a lot of, at least in our program and a lot of the wet labs, that's when a lot of training takes place. But it's in summer when students can really take ownership of their project, work full-time, work extra if they want to, and really get things done. And I think get things done in a meaningful way that contributes to our research program as well. So I think it's also critical for the success of the faculty to have this rich and engaged summer research program.
And I'll just make one last comment. We learned from the Howard Hughes Medical Institute just a couple of years ago that Wellesley has the highest undergraduate publication rate amongst our peers. And I think that's a testament to our activity in research, because we're getting students engaged early. They're able to work with a faculty member, as Mark and others have described, for multiple years, that they're able to really make headway on their own project, and many of our students leave with first or second authorship on their own papers. Something unheard of, certainly, when I was an undergraduate here. So it's really exciting for them, and it sets them up well for success in graduate and professional schools.
That's great. Are there any other questions? I think it's just about 4 o'clock. Yes.
So during my time at Wellesley, I did do the summer research program. I took 2 computer science classes, 2 bio classes. I took one range. One thing I did notice is that I had a lot of experience in research, but when it came to leaving academia and finding a job in industry, I was finding out there was a gap in trying to find a connection to the industry without the network. I've heard that from CS that we have a lot of partners. What about the other departments? What are you doing in terms of connecting
you want me to repeat that? Connecting students who are graduating. In computer science, there were a number of industry connections available for students. Her question is, are there also industry connections available in the other sciences?
So that's a great question. I think from a neuroscience perspective, from our majors, I guess that's one of our shortcomings. We have, of the 5 tenured track faculty, 4 of us have federal funding grants, so we can, I think, provide a lot of great research experience in an academic setting for our students. We don't really have ties to industry in that way as far as collaborative research projects going on that I'm aware of. I don't think anyone in our program does. So I think that probably is a shortcoming of our program. I think one thing that we do in our program is at the 300 level capstone seminar, students, as part of the course, they go out and interview someone who has their dream job. So that allows students, and I've had lots of students who do that, go out into industry and meet people who are working in industry. I know people in industry and can connect students with it in industry, but we don't, now that I'm thinking, we don't really have a lot of students coming out of graduating wanting to go in industry, but maybe that's because we haven't exposed them enough, and that's probably an area we need to work on.
So in the environmental fields, we're building a network of alumni, students, and other people associated with Wellesley. We're calling it the Handprint Network, right? The handprinters are people who have a positive environmental impact as opposed to your footprint. MJ's been there at the symposium. And that we have an annual symposium when we try to bring people together in the same room. And there's a lot of meet and greet, as well as just table-based discussions of hot topics. So far, it's mostly been around food and water infrastructure. We've got some philosophers engaging this year, as well as our engineering professor. It's very interdisciplinary, but those connections to alumni who are working in the field right now are a critical part of what attracts students to that event and the other programming around it. So it's November 4th, if anybody wants to look it up, or you can just Google projecthandprint.org. That's one of the big things that I think it's really a sort of a subset of the alumni network that's focused on environmental issues. And I've gotten really great response from the alumni that participate as well, that it's a way to really contribute back to the college and see what's happening with today's students, as well as participate in current discussions.
We also, as part of the summer research program, build into that programming activities such as graduate panels and career panels. And so we bring back people who are in industry as part of the summer program to interface with students during that time. It's not a lot, but it's something. Our Center for Work and Service also does a career fair every year that is focused explicitly on the sciences. And they bring in industry partners who are available to talk with students about opportunities and resumes as well. So we still have more work to do, but we're doing something. Probably not enough. Okay?
I just have a funny question maybe, but a few years ago, you were talking about having a green living wall in the science center. Is that still
We tried it, and there wasn't enough light in the focus. We decided that putting lights on our green wall, which is what we did, was sort of defeating part of the purpose. We're optimistic that with a new focus, we may have a clearer roof and that we could do a green wall. Yeah.
That's great. Yes.
It's relating to retaining students from the more challenging economic situations in the STEM field. What would you be your advice to their schools in terms of public schools where they're attending maybe perhaps? What do you think could help with that aspect of getting them prepared to enter college? What would be your advice?
Let me just paraphrase. What would be the advice of the panel for underrepresented minorities from public schools? What advice would you give the public school to help prepare those students for college?
I think a big part of it is to try to provide some kind of authentic, exciting science experience. Just get them excited about science. Right now, so I have a son who came through the public schools, took AP biology. It was horrible. It was taught to the test. It was all memorization. He hated it. Right now, he's a freshman and doing phage hunters, right? This hands-on doing science your first year, and he loves it again. I was afraid he was lost to science forever. There's a lot of things we're doing at lots of different levels that are turning off students to science. So that just, it's all about building excitement and interest, I think, rather than pounding them with facts.
And of course, to do that, you need teachers who understand it, what it is. And unfortunately, that's not the case in our public school system, and especially in the schools that you're mentioning. So, I mean, that's the intractable problem, right? I guess we need some Wellesley graduates to decide that K through 12 education is will make them make a difference in the world.
Absolutely, yes, yes. Well, thank you all very much. This was very impressive, and I hope you all learned something in terms of what Wellesley's doing these days.
Thank you.